So you have this in your notes. We're going to be stating some reasons for some conclusions. These are kind of like a really mini proof. Really, we're just going from one step to the other. So if you're given some information, what do you know must be true? When you're given information, it helps you know other things are true. That's why that given information is important. So for instance, we're given that the measure of angle 1 is equal to the measure of angle 2. That's important. We can draw a conclusion from that. Because that's true, we can conclude angle 1 is congruent to angle 2. We have to always be able to justify every conclusion we make. The reason we can say angle 1 is congruent to angle 2 is a property we saw in the last podcast, kind of at the end of a proof, and that is the, come on, there we go. We'll ignore the box. Definition of congruence. And actually, I'm going to write that underneath. It looks a little nicer. Plus, I think the board will. All right, so our reason for our conclusion is the definition of congruence. All right, and that just says if two things, it allows us to go from equals to congruent or from congruent to equals. Let's write that underneath there. So we can go from equal to congruent or congruent to equals. We're given that angle 3 and angle 4 are a linear pair. I don't know what happened to angle 4. It went for a walk, but now it's back. Conclusion. Angle 3 and angle 4 are supplementary. So why can we conclude that angle 3 and angle 4 must be supplementary just because they're a linear pair? Well, that's the definition. Okay. I thought I wrote the I already. Definition of linear pair. That's what linear pair means. We could also say linear pair angles are supplementary. That is a perfectly good justification why these angles have to be supplementary. We're given that angle 5 is congruent to angle 6. We can make this conclusion. Angle 6 is congruent to angle 5. Why can we say angle 6 is congruent to angle 5? Just because we know angle 5 is congruent to angle 6. Right? In your head, do you know which property I'm going to write down? You can tell me how if you got it, if you knew before I was going to write it down. It's a symmetric property. It's hard to write sometimes when I'm not sure where the letters are until after I've written them. All right, so that's the symmetric property. Okay. And it just means we can switch sides, right, on when we have an equals or congruent. Given x is the midpoint of mn, and n must have went for a walk with angle 4 because he's missing. There, now he's back. Given x is the midpoint of mn, conclusion, segment mx is congruent to segment nx. Why can we conclude that? Just because x is the midpoint of segment mn. Well, we know a midpoint divides a segment in half. And each of those halves is going to be equal to one another. And then finally, given a ray AD, let's get the ray symbol up there. I can't type them, and then when I erase the board, sometimes I erase my symbols. Ray AD bisects angle BAC. Conclusion, angle DAB is congruent to angle DAC. Think in your head why this has to be true. I talked about this when we were doing constructions. We know that an angle bisector divides an angle into two congruent angles. I also, and that was actually, not only did we talk about it during construction, we actually defined that, right, in our activity. I put here midpoint divides a segment in half. I could also write, and maybe just in keeping with what I just wrote for angle, a midpoint divides a segment into two congruent segments. I like that better. And let's put my symbol back. There we go. All right, so these were what I call super mini proofs. Really, we're just, what can we say? If we're given some information, what can we say? Let's continue. With a few more. All right, so we're going to state the conclusion and justify. And actually, I have the conclusion up here. We're going to put the justification. So RM is congruent, segment RM is congruent to segment AT. Conclusion, the measure of RM, segment RM, equals the measure of segment AT. Well, how can we justify that? Which of our properties could we use? Think in your head before I write it down. It is the definition of congruence. All right, we just went from congruent to equals. That's the definition of congruent. Angle 5 is congruent to angle 6. What could we use to justify why those two angles are congruent? Well, let's think. What kind of angles are they? They are vertical angles. And we know vertical angles are always congruent. AB is congruent to BC. Okay? Not only it's on our diagram, because each of the AB and BC both have one little hash mark, and it's also written above. What conclusion can we draw from the fact that AB is congruent to BC? We can conclude that B is a midpoint. Well, how can we justify saying that? We know a midpoint divides a segment into two congruent segments. Notice that two of these are the reverse of what we have on the other page. So on here we went from measure to congruent. And on number 4, we went from midpoint to congruent. Over here, we went from congruent to equals. And we went from congruent to midpoint. So many of our definitions are going to work both ways, right? If then that's why we can use them, because they work both ways, all right? If AB is congruent to BC, B has to be a midpoint. It's dividing the segment in half. And if B divides the segment in half, it has to be a midpoint. And therefore, AB has to be congruent to BC. Right? So so many of our theorems and definitions are going to work both ways. Let's do a few more. All right, so let's state the conclusion and justify. So our conclusion, angle 5 plus angle 6 are supplementary. Or we could say angle 5 plus angle 6 equals 180 degrees. Either of those would be good conclusions. How can we justify those conclusions? Well, let's think. What kind of angles are they? We know linear pair angles are always supplementary. Or in the case of our second conclusion there, Let's write it. Add to 180 degrees. Let's look at the next one. AB plus, so here we have a segment, right? We have a segment. There's point A is one end of is an endpoint on that line segment. Point C is another endpoint on that line segment, and point B is a point on that line segment. My conclusion is AB, segment AB plus segment BC equals segment AC. Justification. We have not talked about that in our proof lessons yet, but it was on a homework. What are we doing there? We're adding up the pieces to equal the whole. What are our pieces? What are our whole? These are segments. This is segment addition postulate. So you can add up segments, pieces of a segment, to equal the whole segment. It's very similar just to addition postulate, where you're just adding up numbers, except we're adding up segments instead of numbers. All right, so here we have some angles, and we're told that, now we don't know that those are congruent angles. We don't know DBA is congruent to angle CBA, but we do know that angle, based on our diagram, something we can conclude that angle DBA plus angle ABC equals angle DBC. What were we doing there? All right, so we took this angle, angle DBA, and we added angle ABC, and together we got the whole angle. This is angle addition postulate. We're just adding up parts of an angle to equal the whole angle. Now that is a conclusion I can make because together those two angles make up the whole angle there. I could not conclude that the angles are congruent. Even if it looked like it to me, I could not conclude those angles are congruent because I have no evidence that they are congruent. And that's just a sketch. Just because they look like they might be doesn't mean they are. All right, so here we have another diagram. Notice this diagram is very much like the other diagram, except for one thing. We see some congruence marks. Those congruent marks are telling us our angles are congruent. A conclusion we can make, since angle ADB is congruent to angle DBC, DB is an angle bisector. Right, so it would not be a conclusion to state that angle ADB is congruent to angle CDB, right, because we're told that. That's a given. That marking is given to us. Right? But it would be a fair conclusion to now know that ray DB would have to be an angle bisector, because we know an angle bisector divides an angle into two congruent angles. That's something we know. All right, so this is just some examples of how we use our definitions and proofs, definitions, postulates, and theorems to be able to justify conclusions we make from given information. And that's where I'm going to end this podcast. In the next podcast, we're going to talk about some parallel lines. Bye for now.